Good morning. So last time we finished the line coding techniques. We studied different line coding techniques, unipolar, polar, bipolar, multi-level, and multi-line. So now the last part in chapter 4 is two other techniques, which are block coding and scrambling. Now, after we studied different line coding techniques, we found that there are some challenges in line coding technique and some disadvantages, such as the DC component, the baseline wandering, and the self-synchronization. And some techniques have large bandwidths. So instead of implementing a large complex line coding techniques, we can add block coding or scrambling to the previous line coding techniques. Why we need block coding? We need block coding to ensure synchronization and provide error detection. So the main problem in line coding, if we have large sequence of consecutive zeros or consecutive ones. So always if you have large number of consecutive zeros or consecutive ones, we'll have a problem in line coding techniques. So to solve this, we use a block coding where we exchange every m bits to n bits. So now we don't generate a signal. We still at the data level. So if we have long sequence of zeros, we need directly to apply line coding to generate digital signals, we'll have a problem as we discussed last time, and different line coding techniques try to solve this problem. Loop coding can also solve this problem by replace each m bit with another n bits. For example, I can remove these zeros and exchange them with مثلا 1001, for example. So by this exchange or substitution, we can avoid long zeros. And we also can provide error detection. We can use some codes for error detection, as we'll see. البلوك كودينج بقى different block coding techniques we give them symbols M B N B B binary M bits will be exchanged to N bits. So please don't confuse with we studied multi-level. Multi-level can النيم بتاعه كان ايه؟ What's the name of the multi-level؟ لو عشان مشتغل في الكويز ما ذاكرتوش. كان المالتي ليفل ام بي ان ال without slash. Now block coding M B N B. So don't confuse between the multi-level symbol and the block coding symbol. Okay. So block coding will have M B M bits, and I need to exchange them with N bits. So we'll have three steps: division, where we divide the bits into blocks. Then substitution, substitute each block by n bits to n bits. Then combination again. So this mean three steps of block coding. We'll have sequence of bits. We will divide them into blocks. Each block contain m bits. Then we will substitute each m bits were n bits. Okay. So it's very simple. It's just exchanging m bits to n bits. Okay. For example, non return to 0i كان الباندويث بتاعك كام؟ برضه باندويث اوف نون ريتيرن تو 0 اي. هو ده داخل في الكويز. اوكي. ان اوفر 2. فالباندويث كانت كويسه لان مانشستر مثلا وديفرنشال مانشستر كان كام؟ كان ان كان لارج. فالنون ريتيرن تو 0 اي كان ان اوفر 2. بس نون ريتيرن تو 0 اي كان عنده بروبلم اوف سينكرونايزيشن لان كان ايه اللي بيحصل فيه؟ كان ال1 ميك انفرجن اند 0 كونستانت ولا العكس؟ افتكروا انتوا بقى. فهو كان يعني فالنون return to zero has good signal rate but has a problem of synchronization if we have long sequence of zeros. Okay. To solve the problem of non-return to zero I and the benefits from the bandwidth, from its bandwidth, we can add the block coding to the N0I. But before we apply N0I, we can add extra block for block coding. So the coming bits, if we have long sequence of zero, we'll exchange every 4 bits by 5 bits, then apply NR, non-return to zero I, then make it decoding and decoding of the block coding. So by this method, we benefit from a non-return to zero I bandwidth, and we avoid a long sequence of zero that make a problem in synchronization by applying the block coding. Okay, this is example for block coding for B5B, where we exchange every 4 bits from the data, we encode them by 5 bits. Okay, and we can use extra combination for quiet, for reset, for error detection, and so on. So we can use fixed codes to make error detection as a receiver, or to make reset, or set, or start timer, or so on. So the extra combination or extra codes, we can use them for other purposes, where the main combination we exchange every 4 bits with 5 bits. Okay, clear the main idea of block coding, why we need block coding. Okay, if we have an extreme case, if we make this exchange and we exchange every 4 bits by 5 bits, and we move we made the block coding, but by chance the generated number at the beginning, so we'll still have some zeros. So for extra avoidance of long number of zeros, we can make substitutions. So we can combine, we can exchange the order of the blocks as the generated output. So instead of we have block 1, block 2, block 3, we can generate block 2, then block 1, then block 3, and so on. So we can make also substitution. When a different group after combination generates new sequence without zeros. Okay? So we can also make يعني randomization of the blocks after البلوك coding. طيب what's the disadvantage بقى في البلوك coding if we use مثلا 4B 5B. what is the main disadvantage؟ الادفانتج خلاص we will avoid consecutive zeros وبالتالي we solve. But what's the disadvantage؟ when we exchange each 4 bits by 5 bits we increase the number of bits. And if we have مثلا 40 bits, every 4 exchanged by 5 will generate 50 bits, while the original can 40. So we increase the number of bits, so we increase the signal rate. We will need more bandwidth in this case. And احنا we didn't change each 4 by 4, that was change it 4 by 5. So we increase the data, so we need more bandwidth. So the main disadvantage here is we need more bandwidth. Another bad complicated block coding techniques, if we need to implement 8B by 10B, we exchange every 8 bits by 10 bits. We can make this on 2 steps. Exchange first 5 by 6 and exchange the last 3 bits by 4 bits. يبقى كده 5 و 3 ال 8 bits, we generated 6 and 4 10 bits. But these two blocks we will feed them to disparity controller. Why about we make this complex architecture and use disparity? Disparity controller track the excessive zeros or excessive one. If we have many zeros, large number of zeros compared to one, it can make the inverse. It will exchange zeros to one. Or if the bit in the current block creates disparity, it contribute to the previous disparity. يعني we'll have large number of zeros after block coding, after encoding, then each bit is complemented. Zero is changed to one and the one is changed to zero as a disparity controller to avoid more consecutive zeros or consecutive ones. يعني دي extra degree of enhancement. يعني هو ال 5 bits 6 bit المفروض to generate good result, but even if by chance البلوك generated block after combination still have some zeros, we can use disparity controller to complement the zeros to ones or ones to zero to balance the number of zeros and number of ones and to avoid long zeros and long ones. So this extra enhancement option by using disparity controller. Okay, but still until now we still have the problem of large bandwidths or increasing signal rates because I exchange with large number of bits. فالother solution بقى هو scrambling. Scrambling will not add extra bits, will exchange exactly m bits by another m bits by another code. Okay, so the main aim of scrambling is to doesn't increase the bandwidth while provide synchronization and avoid this component. But I need to solve the synchronization problem, avoid this component while at the same time so I don't want to increase the bandwidth, but I need to solve this synchronization and this component. So scrambling used to create sequence of bits that has self-clocking, no DC, and without increasing the bandwidth. So I will replace what will bad scrambling do? What does it replace a consecutive unwanted zeros with violation code. So instead of exchanging each m bits by n bits, now if I have consecutive zeros, I will exchange them with violation code. Okay, by another code. And at the receiver side, if I found because the violation code is fixed, but if I discover this violation code, I will know this is serious scrambling, and this violation code is representing zeros. So the scrambling now, uh, unlike block coding, which exchange every m bits by n bits, now the scrambling will track only zeros. And if we have zeros, I will exchange them by a violation code. So in this case, does it does the scrambling change the bit rate? No. Then we will find zeros will exchange by violation code with the same length, so we'll have the same number of bits. So we will not increase bandwidth, we will not increase the number of bits, while we will balance the positive and the negative and avoid the DC component. Of how can we make this? By this violation code, we have two cases for B80S. In this scrambling B80S, we need to exchange each 80 by a violation code. Okay. So if we have 8 consecutive zeros, like first example, we will exchange them by 000 bb 0 bb. So each 8 zeros, I will exchange them with this code. If I don't have 8 zeros, I will not do anything. Unlike block coding. Block coding, every n bit exchanged by n bits. whatever بقى دول zeros once I will exchange every n bits by n bits. Now السكرامبلينج لا السكرامبلينج فيها الزيروز and if it finds 8 consecutive zeros it will replace it by this code 0 0 VB 0 VB. طب what will be بقى؟ ال V means that the same polarity as the previous non-zero box. يعني ايه الكلام ده؟ يعني if we have polarity. Then B. Okay. So the scrambling, I discover 8 consecutive zeros. I will replace them by 0 0 0 VB 0 VB, where the V have same polarity like the previous bits, the previous non-zero bits. خلي بالك. Will be make an opposite polarity. طب another example. If the last one is negative and I found 8 zeros, I need to exchange these 8 zeros. فنجيب 0 0 0 بعد كده B like last one بعد after that B نكتب تاني بعد كده 0 بعد كده B same like previous بعد كده B errors. Okay. So if in the exam I give you bits positive and don't use that we have 8 zeros, what will be the output? If we use scrambling, I will apply direct 0 0 0 VB 0 VB. بس take care بقى ان ال V takes the same while ال B take the inverse. So you can generate the output. طب if I give you 1 2 3 1 2 3 4 5 6 7 8 بعد كده give you 1 1 مثلا بعد كده and I said to you make this with scrambling. How many times you will use scrambling? Well, scrambling search for what? 8 zeros. By this 8 zeros. Okay, I will make for them scrambling. Of this I was the same. I will not do anything. I search for 8. I was the same. Those 3 I was the same. If I will use only scrambling one time. But now, if this was 8 zeros, you will use scrambling 2 times. Okay? فتake care about this. Updates على scrambling يعني first scrambling techniques can be 8 zeros S اللي هو substitute H 8 zeros. طب another technique for scrambling HDB 3. Okay, so high density popular 3 zeros. Here in HDB 3 we exchange every 4 zeros بقى. And they found that if I wait for 8 zeros it's يعني long value is large number to wait for 8 zeros. فinstead of 8 zeros I will exchange every 4 zeros. Okay, not 8 zeros like the previous. In this case, if I have consecutive zeros, I will exchange them with 0 0 b or to the last non-zero value. Okay, if a number of non-zero values before substitution odd, we will use 0 0 b. Even اوكي، يبقى ال HDB3 I will exchange every four zeros with a code 00V if we have odd non-zero element before substitution, and B00V if we have even number of non-zero elements before substitution. Any question? Hmm. The value of V هي same value of non-zero element before it. يعني يعني first you have to define what code you will use 00B ولا B00B. فدي أول حاجة. You will define ال four zeros or four consecutive zeros. Then you can بقى plot using ال value of ال B وال V according to ال previous non-zero elements. ال B make inverse, ال V the same polarity. Okay? And main aim طبعا of scrambling to avoid a long number of zeros. Okay? Any question? Any question في chapter 4 كله؟ Okay. So we can start the quiz.